buckle in for the fourth installment of the AP ECE Econ Chemistry Chapter 6 homework review. We're going to look starting at problem number 31. In problem 31, you're asked to write an abbreviated ground state electron configuration. Abbreviated means that you're going to have to find the noble gas in group 18 that is closest to but below the element you're considering in terms of number of electrons, and by consequence also protons. You're asked to do this for part B and part D of number 31, and part B is arsenic, right here, number 33. So you can't use krypton, that's number 36. You got to go back down the periodic table to number 18, argon. So you put argon in brackets, and argon has 18 electrons, and you pick up after that. So a lot of times students will say, well, where do I pick up? Well, if argon finishes the third row, and this is the P block over here, then you find 3P in your filling order and pick up right after there, 4S. So then 4S2, 3D10, 4P3, done and done. 33 electrons have found homes. You are quite the orphanage manager. In 31D, you're dealing with zirconium. So zirconium has a total of 40 electrons, and so you got to find zirconium right there, and you got to find the noble gas that's behind it but close to it, and that's krypton number 36. So krypton, then krypton finishes the let's see, fourth period in the P block, so find 4P and then pick up after that 5S, put 2 of the electrons there, and then after 5S there should be a 4D, and here we go, 4D as you read down your arrows. Let's take a look at problem 37. In problem 37, you're trying to decide whether the given electron configurations are possible in the ground state, meaning like all the electrons are at the lowest possible energy level, in an excited state, meaning like you've skipped over some spots where electrons could fill based on the alpha filling order, or impossible for one reason or another. So if you're given the configuration 1s2, 2s2, 2p1, that's a ground state electron configuration, 1s, 2s, 2p, and you haven't skipped over anything. In part B of number 37, you're trying to fill this thing called the 1p, and it does not exist, so this is an impossible electron configuration. In part C, you have 1s2, 2s2, 2p3, 3s1. That can exist. You haven't fully filled the p sublevel. It could have a capacity of 6 electrons, but that just means one of the electrons in the p has been hit by a proper photon of light to be excited and get pushed into the 3s sublevel. Part D, 1s2, 2s2, 2p6, 3d10. Be careful on this one. You skipped over something. There's 1s, 2s, 2p. Oh, yep, we forgot the 3s. Oh, then also the 3p, and even the 4s before the 3d. So this can exist, but we have 10 electrons that have been excited from lower energy levels up to the 3d. For part E, you've got 1s2, 2s2, 2p5, 3s1. You have not filled 2p, and you have excited an electron to a higher energy level. Let's take a look at 39. Alright, in 39 you're asked to draw an orbital diagram. So this is a pictorial representation of your electron configuration, and in it you use these little lines to represent individual orbitals, and you label them underneath, and the arrows represent electrons. Up arrow is a positive 1/2 spin, down arrow is negative 1/2 spin. So you have to find homes for iron's 26 electrons, and you start to fill in 1s2, 2s2, 2p6. So that's why you've got an orbital here. It would be like the 2px, 2py, 2pz. Then 3s, we're still following our filling order, 1s, 2s, 2p, then 3s. Then we go to 3p, we're still filling. Then we go to 4s, and then finally into the 3d. We start to plop down electrons into there, and we keep them unpaired to start before we have to pair them, but in order to find homes for 26 of them, we do have to pair off one of those. They stay unpaired first based on Hund's rule.